Read the question carefully. It says the amount spent annually from 2010, that's when t equals 0, is expected to grow at the rate of this is the rate of change of amount spent. So that's the derivative of amount spent, so spending. So we can say this is same as spending, let's say S prime. Okay, $1 billion per year. The national spending in 2010 was 317 billion. 2010 means t equals 0. Okay, so this is the spending on the base year 0 equals 317. What is the projected national spending in 2016? 2016 means t equals 1. 2011, so that's t equals 6. So spending at t equals 6. Okay, so we integrate this function and find the spending S. So here the spending is just the antiderivative of this rate of change of spending. So 1.0952 t plus 1.357 dt. Okay, let's integrate this. This constant survives. 952. Antiderivative of t is t square over 2 plus antiderivative of this constant is just this constant t plus constant of integration. That's the amount spent at year t. But we need to find the value of c because this is arbitrary constant, any constant, and it's given that the national spending in 2010 was 317 billion. That's when t equals 0. So when we plug t equals 0, then we get c 317. So that is, yes, t is, we can divide this by 2 or just leave 952 t square over 2 plus 1.357 t plus, when we plug t equals 0, this becomes 0, this becomes 0, so this is 317. That means c equals 317. So I'm replacing c by 317. So this is the amount spent in any year t. Okay, now we need to find the projected national spending in 2016. So replace t by 6. Then S6 is equal to 1.0952 times t is 6 is square over 2 plus 1.357 times 6 plus 317. Now use your calculator and you're gonna get 344.8556. that's if you go $1 billion, okay, that many billion. Final